Good morning, my name is Emmanuel Jaques,
And my name is Kevin Garcilañas.
and this time we present the last activity for the 5 unit.
In this final project, we are going to control the position of a motor by means of a PID controller, which is going to be connected with Arduino. The intention is to improve the motor control system, obtaining a more stable system. We will do it with the data that by default we have in Arduino, and then we will change the data for a stable control system in the PID.
For the first part of the activity, we, we show the graphic with the first values of the PID. In this case, the PID values have the next ones. In this part, we can see what is the values of the PID. So, in Proteus, we need compile the code of Arduino for can view what is the values of the pulses and what is the quantity of the pulses. For know what is the quantity of the pulses, we have the next data for obtain these results. Making of these operations, we have a position equal 30, revolutions equal 12, and pulses equal 288. So, how can view the modern functions? Um, for view the modern function is necessary up the file .x of the Arduino previously charger and press play for run the application. We can see the oscilloscope and the virtual terminal. So the pulses is equal 288. So we need type into the virtual terminal the value of the pulses. In this case is 288 and press enter. We can see how the pulses is begin and the motor are moving. The motor is moving, sorry. The system is a little slow, so previously we make this part for save time, and the in this Excel we have all the data from the first file with the PID of Arduino, and we can see the virtual of the Proteus generate 6413 data. All this data we need into MATLAB, and we can see in this part we can see all the data uh, copied of the Excel, and the quantity total are 6413, and this is of the data for view the first graph of the system. Just running, and this is the graph.
Okay, this is the first graph, and we can see how is the unstable system, um, because it's for these variations.
For the second part of the activity, we need change this graphic. So we need these oscillations change and just have our unique pulse. For this, we have make to Proteus or shares in Proteus the second file with the second values of the Arduino. The new values of Arduino just we change these values for
Is
for
8.
8,
Okay, is
8
and 6.
6. These are the new values for the PID, and just need compile for generate the next X. In this, in my case, in my computer, the delivery has a error, but we we generate the X in the Arduino of the computer with my partner. My partner shows how we compile and function the code. Once the code is compiled, just need generate the .x and charge it to Proteus. But for save time, we have shared the file x is this the file of the x, and just we need make the same of the first parts of the Proteus. We type the same pulses, and for the same situation of the next and of the previous part, the motor and the virtual terminal are a little slow, and previously we have the data of this part is this, and we can see the data are not so much as the first part. So we copy this new data, and type in MATLAB. We have 3666 data. Just need put in this part the quantity of the data and run the graphic.
Okay, we can see the second graphic. This is with the data that we finally have in the pit, and we can see how the system is stable, because the value is changed, and so the graph is in this case is stable.
Okay, for our part is all. In conclusions, we can see the importance of the use PID in a control system, and calculate the values of the PID correct for have a system stable. Thank you.